Well, good morning. I'm glad to see you're with me to do some math. Try and knock out another page here. I'm looking at number 40 on down. So we're still in the factoring stages. We're supposed to factor 4r squared plus 16rs minus 10s squared. Now this one's got two variables in it. It doesn't have equality because you cannot solve for two variables with one equation. It takes two equations. But anyways, I don't think it'll be too bad. To create a 4r, we need a 2r and a 2r. And, my gut says 5 and 2 on 10, but that won't work, will it? I don't think it'll work. 5 would be 10, 2 would be 4. I could do 10 and 1. That would make 20 and 2. So, cross that out. Try 4r and r. And the goal is still to get to 18. I could put a 10 here and a 1 here. That'd make 14. I could put a 10 here. Well, I could put a 5 here and a 1 here. That won't work. I think we have another prime. So what I'm kind of doing in my head is, and probably I should be writing this out. This would make 10, and this would make negative 4. That won't give me to 16. It has to be a negative times a positive to make that negative. I need my s too. I'm not even thinking about my s. But that's going to be negative 10, and that's going to be still 4. So I know the 2r's don't work. So I think about the 4r's. If I try a 10s and a single s, I'd have 40s, and I'd have an s. That won't get me to 16. So I try again. This time I guess I can put the 10 here and the single s there. And that's 10 RS and 4 RS. And the goal is to get 16. So 40 is prime. It happens. That's a prime factor. 41, we'll just see, we got some P's and some Q's. Let's try a 6P and a 2P. And let's try a 5Q here and a Q there. And that should work. That's going to make 30 PQ. That's going to make 2 PQ. I just said it would work, but no, it's not going to. Because in order for this to be a negative, one of these has to be negative. If I make that one negative, I'm not going to get to negative 32. So this factorization doesn't work. Doesn't mean another one doesn't work. But that factorization didn't work for me. Probably they needed a different symbolism going on in here. All right, what else can we try? If I put the 5 here and the 2 there, that'd give me 5 and 12, 17. So the 6P and 2P is probably done. I can try a 4P and a 3P. And the factors of 5 are still 5 and 1. This isn't looking too good, is it? Because if I put a 5Q here and a single Q here, that's going to be 20, and then it's going to be 3. That's not 32. So I could go ahead and I could rearrange things a little bit. I could put a 5 here and a 1 there, and that's going to make 15 and 4, which is not 32. I believe 41 is also prime, although I have not played with 12P and a single P, and I'm just not feeling that one either. If I put a 5 here and a 1 there, I'm looking at 17 again, because 5 and 12 make 17. If I put a 5 here and a 1 here, I'm looking at 60. That's too far away. So I'm going to go with prime. 2 primes in a row. 42. Difference 2 squares. 42 is an r squared squared minus a 4s squared squared. All right. The difference to squares patterns, by the way, is a squared minus b squared equals a minus b times a plus b. So when I go through on this one, I'm going to have r squared minus 4s squared times r squared plus 4s squared. But I'm not actually done, because this guy right here is also a dots pattern. This guy right here is an r that is squared, take away a 2s that is squared. So this leading factor factors again, it has more factors. It's going to be r minus 2s times r plus 2s, and then my r squared plus 4s squared. There's always some kid who wants to factor the sum of two squares, but there's no pattern for it. It will not factor, not with real numbers. It takes imaginary numbers. 43 has equality, which means we actually get to figure out what x is. It's not a hard one to factor. To create an x to the fourth, you take an x squared and x squared. To create a 4, you need a 4 and a 1. We want to be negative 3, so minus 4, add 1. This is a solve by factoring. This is a dots pattern, difference of two squares. Factors is x minus 2 times x plus 2. And then we just use our cover-up technique. X squared plus 1 is 0. X minus 2 is 0. X plus 2 is 0. So these two right here where my pinky fingers are, they're easy. That's x is 2, and that's x is negative 2. And believe it or not, you guys already know about this one. If you subtract the 1, you get that x squared is negative 1. The opposite of squaring is the square root. And you guys already did the lesson on imaginary numbers. So there's always a plus or minus symbol. The square root of a number is always plus or minus. And the square root of negative 1 is actually defined to be I. That thing has two imaginary answers and two real numbers, and by God, 2 plus 2 is 4. 4 solutions. Another one of these to the fourth power, z to the fourth minus 10z squared plus 9 is 0. That'll take a z squared and a z squared. 9 factors of 9 that add to 10 are 9 and 1. Minus 9 minus 1. We have the dots pattern in front of us. Z squared minus 9 factors is z minus 3 times z plus 3. And z squared minus 1 factors is z minus 1 times z plus 1. And then we use the cover-up technique. Positive 3, negative 3, positive 1, negative 1. So z is 3, negative 3, 1, or negative 1. 45. Rolling on. X squared minus 3x plus 2. It's not equal to 0. Wow, this is easy. Like, why is this even in there? And then x minus 2, x minus 1. Done. 46. 9t squared plus 6t plus 1. To create a 9t squared, I'll use a 3t and a t. To create the 1, I'll use a 1 and a 1. And it'll work. Know it? That's 3t. 3t. Get my 6t. 47, 27x cubed minus x minus 6 equals 6. So when you move this guy over, you now have a negative 6 plus a 6, which is 0. 27 and 12, last I checked, are both divisible by 3. X cubed and x are both divisible by x. So I'm going to pull those numbers out and see what happens. That'll give me 9x squared minus 4. By the way, still equal to 0. 9x squared minus 4 is the dots pattern. Factors is 3x minus 2 times 3x plus 2. And now I can do my 3 equations. There's actually 3 answers here. See that 3? 3 answers. First one is on that first factor. 3x is a factor. So 3x is nothing, which means that x is nothing. 3 times 0 has to be 0. 3x minus 2 is 0. Add 2, divide by 3. X is 2/3. 3x plus 2 is 0. Subtract 2. Divide by 3, negative 2/3. And moving on. Solve by taking square roots or factoring if possible. Always simplify your radical. First one factors. Or does it? No, it doesn't factor. Ignore me. We're just going to move that 48 to the other side. We're going to divide by 4. That'll give us 12. So x is going to be plus or minus the root of 12, and you have to simplify, okay? Because the opposite of squaring is square rooting. 12 is 4 times 3. The square root of 4 is 2. So plus or minus 2 root 3. 49, 27, and 36 are both divisible by 3 or 9. If you pull a 3 out of it, you still can't factor. It's just another problem. So same as last time, move your 36 over. Divide out the 27. Simplify. What do we divisible by here? 9. 4 over 3. Counteract squaring with square roots. Don't forget the plus or minus symbol. Never forget the plus or minus symbol. The square root of 4 is 2, and you got to clean this up. It says always simplify your radical. To somebody a long time ago, I don't have a clue who they are because it was 1600s or so, said no radicals in the denominator. So we multiply the numerator and denominator by the root 3. So we go plus or minus 2 root 3 over 3. Let's see, instructions actually say on 50 complete the table. So here's your question. 2/5 of x plus 3 squared minus 4 is 4. And the first reason they give on this little thing is the addition property of equality. So what they're saying is we add 4 to each side. So if we were to add 4 to each side, we should have a line that says 2/5 x plus 3 squared equal to 8. And then you can see here that something happened. X plus 3 squared is 20. Well, it turns out if you take an 8 and you divide it by 2/5, you get 20. So it's the division property of equality. That's what happened. Let's see, what's the reason for line 3? Counteract squaring and simplify the radical on the right-hand side. So if we counteract squaring, we would have x plus 3, I don't need the parentheses anymore, x plus 3 equal to, we'd have a plus or minus symbol, root 8. Now root 8 is 4 times 2, and the root of 4 is 2, so plus or minus 2 root 2. Next up we have the subtraction property of equality, because we're playing the isolation game. That 3 has to come over. So negative 3 plus 2 root 2, or negative 3 minus 2 root 2. Oh, there's two 50s. Nice. Second 50. Just like for the one before it, there's just no table. So let's go through the same process here. I'll probably do this in more steps than the table suggested. Negative 3/4 of x minus 5 all squared is negative 6. I'm going to multiply by 4. Each side gets forward. Cancellation. Negative 3 times x minus 5 squared is negative 24. Divide out my negative 3. X minus 5 all squared is now 8. Oh, it's an 8. Counteract squaring by square rooting. The square root of something squared is the content inside. We already know the square root of 8 simplifies as plus or minus 2 root 2 because we just did the previous number 50. And then we're going to add 5. So there's two answers here. There's 5 plus 2 root 2 and there's 5 minus 2 root 2. So x is 5 plus 2 root 2 or x is 5 minus 2 root 2. I'm gonna go ahead and stop the video so it doesn't crash, and I got some of it done, but I'll come right back in just a minute and finish this homework assignment.